Today I'm going to teach you how to solve a stoichiometric problem. A researcher produced 1.89 grams of lead phosphate, our actual yield, by reacting 3.57 grams of lead nitrate with 4.72 grams of sodium phosphate. Question: what is the theoretical yield, limiting reagent, and percent yield? Okay, I'm going to start by converting the 3.57 grams of lead to nitrate. I'm going to make my bridge nice and long. Stick to support it. Whatever unit's on top, I'm going to bring it to the bottom on the other side here because I want to cross cancel these. Now, I have grams. I'm thinking, well, what should I use? Well, the balanced equation is in terms of moles. So grams per mole, molar mass. The molar mass of lead to nitrate is 331 grams per mole. Lead to nitrate. Okay, what's sweet about this is that the grams per mole cancel, and now we're in terms of mole. So whatever unit's on top, we want to put it on the bottom so we can cancel this. So it's going to be lead to nitrate. If we go to the balanced equation, we'll notice that there are 3 lead nitrates, lead 2 nitrates, to 1 mole of lead 2 phosphate, the Pb3PO4 with a 2 on the outside. And again, the moles cancel, moles nitrate. So now we're in terms of lead phosphate. So whatever unit's on top, let's put it on the bottom. And since we're dealing with theoretical yield, we're going to want this to end up in grams because we're looking at yields. So we're going to use molar mass again. So the molar mass of lead phosphate is 811 grams. Okay, let's make this a little smaller. Move it over to the side. And the answer, also let's cross cancel. Let's cross cancel the lead phosphate moles and give you the numerical answer of 2.92 grams lead 2 phosphate. And now let's convert the 4.72 grams of sodium phosphate. Let's make a long bridge. Stick to support. Whatever you know on top, put it on the bottom. Grams Na, 3PO4, and it's 164 grams per mole. Bridge. Let's cancel the grams. Gone. Whatever unit's up top, put it on the bottom. Notice that there are 2 moles from the balanced equation. So the unit on top goes on bottom again. PO4. And 1 mole Pb3 PO4 2. And we'll again cross cancel the units. And now we're in terms of mole lead 2 phosphate, just like before. Notice that we end up using the same molar mass. This makes life slightly convenient. 811 grams Pb3 Okay, I'm going to resize this so that fits a little more. Okay, and I'm also going to give you the answer, and that's going to be 11.67 grams lead 2 phosphate. Now, both of these answers can't be correct. So, the theoretical yield is actually the smaller number. That is your theoretical yield. So that means the 3.57 grams of lead nitrate is your limiting reagent. It will not allow you to make any more. There's not enough moles lead 2 nitrate to react with all the sodium phosphate. So that also means the sodium phosphate is the excess reagent. So now you know several things. You now know the theoretical yield, the limiting reagent, and the excess reagent. To determine the percent yield, you're going to take the actual yield, AY, which is found in the word problem, divide it by the theoretical yield, which you actually calculated, times 100%. So the actual yield in this particular problem is 1.89 grams lead 2 phosphate, the PB3PO4 by 2, divided by 2.92 grams times 100%. What that's going to equal is 64.7%. Just a little more than 50%. That's how you do a complete stoichiometric problem. I hope this helps. Thanks.